Oh, hey guys, I didn't see you there. So, Goldilocks and the Three Planets. Today, we're going to talk about what is Goldilocks zone? Why does it matter? What purpose does it have? And how there can be more than one Goldilocks zone in a solar system, just like in our own. So, let's go to the whiteboard and let's start talking about Goldilocks and the Three Planets.
Alright, so the Goldilocks zone. In short, what it is let's say we have a star right here, and we have a bunch of planets right here. So, with that and that there, what it is it's the range right here to right here, roughly, that it's not too close to the star right here, and it's not too far away. See, if it's too close, then what happens to all that liquid water, which science has told us is a very, very essential building block for life, because we are 70% water. Ooh, I better watch where I'm pointing that thing. And everything around us needs water. So if it's too close to the star, then what's going to happen is all that water is going to evaporate away. And if it's too far away, then what's going to happen is it's going to freeze. And I don't know if you know anything about cryogenically frozen or anything, but life basically stops. So if it's frozen and it's cold enough, even if there was possible life, nothing can happen because that water is frozen. Now, another really cool thing about Goldilocks zone is, even though we'll say all the way over here, where basically Jupiter or Saturn is in our solar system, this is way outside the Goldilocks zone here. So what's really cool is the moons around, say, this big planet here. Like I said, it could be Saturn or Jupiter or whatever. Well, Jupiter, we'll use Jupiter because Jupiter actually has this happening. If I'm not mistaken, yes, one of its moons, Europa, is being kept warm enough that life could possibly sustain all the way out here, outside of the Goldilocks zone. So what it's doing is, just like Neil deGrasse Tyson said, imagine a racquetball. You warm it up before you play. And what that does is that stress, that strain, that stretch of it going back and forth heats it up. Same thing with Europa all the way out at Jupiter. Now, it's doing the same thing, and there's ice cracks and stuff like that, and it's been frozen, cracked up, refrozen. Imagine going to your freezer after you poured some water in your ice tray, give it about an hour, crack it. It's not all the way frozen, not yet, but you keep doing that. You keep taking it out, letting it warm up slightly, cracking it. That's basically what's happening on the surface of Europa from what we can see. So, not only can there be a Goldilocks zone all the way up here near the star, but there can be one all the way out there. And that completely broadens the horizon for how we can look for new life, because originally we were just looking for possible actual habitable zones away from a star. Well, now we have to look at the planets outside of the habitable zone and look at their moons and see if something like this could possibly be happening. But so in conclusion, habitable zones are our prime hunting spot for any new life. Now, life may not look like me or you or, the animals around us and stuff like that. We found evidence of life on a few different planets, and it's all different things like microorganisms, bacteria, germs, and things like that. But that doesn't mean that it's not life. That is still life. It's not as evolved as us to be able to make videos about life on other planets. It's not to that point yet, but it's still life. And who knows? The universe is quite big. There's definitely a lot of possibilities out there. So, hope you guys enjoyed this video. Don't forget to check out the description. Alright guys, that's the end of another awesome science video. If you haven't yet, subscribe, click the notification bell, leave a like, leave a comment, share this video with people you know. Stay curious, stay random.